Okay, so let's go and take a look at a few slides. I prepared some materials on discrete event modeling and on system dynamics here. Because we don't have time to do all the hybrid modeling today, I'm going to defer my discussion of system dynamics until tomorrow, where we'll be talking about it. We'll be building hybrid system dynamics agent-based models at that point. And we'll see there's many such model types. There's system dynamics models which bud off agents at a certain point of severity in their progression and health status. There are system dynamics models that live within agents. There's system dynamics models that total up things across populations of agents, where they're at the global level. There's some within agents, and there's some where agents are sort of horizontally associated with them, where the agents bud off. We're going to see that tomorrow. I'm not going to go into that now, nor am I going to go into an explanation of system dynamics now. Instead, that will wait till tomorrow. I would like to instead today talk about another type of modeling we'll be using, which is discrete event modeling. And I just want to orient you with respect to this. It's an extremely rich, extremely well-established, in some areas almost codified process associated with discrete event modeling. This type of modeling is used very widely in the healthcare space, particularly for operational decisions having to do with the processes within care facilities. Discrete event model is a technique that focuses on capturing the impact of resource constraints and in some cases placement, sort of physical routing, on the capacity of the system to process individuals or process entities, as we call them, through the system. In a healthcare context, those are often patients, but they could be other quantities that flow through care processes, things like vials of vaccine or lab samples, etc. So in this context, we're dealing with a defined workflow which is articulated for the system under concern, and we have a set of processes defined associated with that workflow. These processes operate upon entities that flow through the system. Those entities in traditional discrete event modeling tend to be fairly passive, and they tend to be operated upon by the processes rather than engaging in active agency, rather than making decisions, rather than interacting with the environment and other agents. Instead, they're flowing through the set of processes that operate upon them. So, for example, we might represent a hospital-related care process which progressively determines if a CAT scan is needed, and if so, administers some trace medicate or some trace bolus that people have to apply that examines the need for another type of imaging modality and potentially for ultrasound, and determines if that's sufficient, and if not, it goes back and re-examines them, and if it is sufficient, then they get admitted to and get handled by a discharge doctor and a discharge nurse. So here we can map out a process by which patients are handled by successive stages of a care process. Think about yourself going into the hospital and going from station to station to station, getting your wrist sort of band put on, awaiting care in a certain room until a machine is free, going in for diagnostics, coming back out, going to a point where you can get blood work done, and waiting there. These are sort of workflow processes that are defined. Patients will flow through them, and their experience will be shaped a lot by the availability of resources, whether they're kept waiting and how long they're kept waiting. This is shaped by availability of resources. So it's often particularly focused on resource-constrained modeling. These resources could vary from human resources such as clinicians of various sorts, doctors and nurses, to fixed resources, things like availability of an MRI machine, of a free time slot with an MRI machine, or with a CAT scan. It could also go to the point of dealing with resources that are portable, such as gurneys or portable X-ray machines, portable ultrasound scanners that are rolled around, or beds. So here we have a number of components that are often of keen interest: the presence of queues, of waiting lists, and waiting times. There are these processes that are operating on the entities, and it's really a sort of process-centric modeling with defined processes. We have these sort of workflow diagrams, and we typically have these capacitated pools, these pools that only have a certain capacity associated with them. So in this context, we're dealing with a modeling methodology that can really crisply represent, using these defined operators, these sort of predefined little bits of logic, these logical blocks. They can represent processing in the context of limited resources. And you can identify, for example, the impact on health service delivery, the time of care, and potentially some aspects of the quality of care conferred based on level of resources available, the coordination between those resources, where those resources are placed in space, the impact of facility layout. And this can be done with only a very modest amount of programming. So you can define these things in ways that make use of predefined blocks. You can stitch together, and typically you're not writing a lot of code to back it up. You're dealing with these tried and true sort of little mechanisms that work for a lot of simple cases. Now it gets much more complex if you try to represent the full sort of textured context of a larger hospital, where there's all sorts of issues of interacting entities and agents and resource interactions. But for small, simple processes with sort of defined workflow, rather than highly variable workflow, this can work pretty well as a way of characterizing the flow through such facilities. And we're going to try applying this method in a hybrid context, together with our model of the clinic here, okay? So, shall we begin? Okay. So, ladies and gentlemen, we have this model, and this model captures a lot of the salient features of the situation, but alas, not all. We're going to have to add in some pieces to it to characterize the care process, to add in elements beyond this, showing how people are treated within the facility, okay? So, ladies and gentlemen, the main thing we're going to modify here is the representation of the clinic. Right now, we go to the clinic physically. The patients go to the clinic, and where do they go to the clinic? They depart for it right here. But the clinic is under-conceptualized, to say the least. They arrive at it, they spend exactly 1 day at it, and they leave. And that leaves us no understanding as, for example, how does the number of nurses available at that clinic affect how quickly they get treated? How does it affect the quality of care, their likelihood of being cured? That's all brushed under the rug here. And we're going to go through a process which will help us be able to answer questions like that. Help us be able to answer questions like, how does the number of clinics available in the area affect the prevalence of illness within the population? So can we do that? Let's do that together. Okay, so the first element is going to be expanding the clinic to enrich its representation. And this, ladies and gentlemen, will require another stretch of your comfort zone, okay? So you can click on clinic here, and the TAs should prepare for deployment, okay? Okay, so I double-clicked on clinic, and right now we recognize that clinic is not recommended by much detail. It has a certain representation, and that's about all visually. So, ladies and gentlemen, I'd like us to go to a palette which we have yet to explore. And it's a palette down here in the in the space. I'm trying to find it here. I'm sorry? Okay, yes. No, that's not the action chart. There it is, process modeling library. There we go. It's a blue box here. It's a couple under the state chart. Process modeling library. Okay? This is process-centric modeling that we're looking at. So we're going to define a workflow process. And what is going to be a strong determiner of how long things take in the workflow process? It's going to be resources, in particular the availability of healthcare workers. Okay? So let us add the components of this. And we're going to only represent the most basic process. Ladies and gentlemen, I'd like you to scroll down until you get to a little block that says enter. Do you see that? You scroll down in the palette. Okay, let's drag it up there. And let's call it walk-in. Okay, we're going to be dealing with walk-in sort of situations where you walk in to the clinic. Okay? Okay. And next, we're going to have a representation of a situation where we need to get access to a resource. We need to be seen by a healthcare worker. And I just drag this in, and I am going to associate it with a name of reserve, or what should we call it? Reserve healthcare worker. It's really an assignment to a healthcare worker. Okay. I dragged in a C's. It sounds transgressive, but it's down here in the process modeling library, and it's the terminology of art to indicate you're reserving a certain resource for use. There's a certain resource reserved for use. I dragged it in, and it automatically showed this little line between them. If it didn't for you, if that broke, you could double-click here, double-click there, or double-click here, and I think drag over and click there. I think is how it works. Okay? Okay, so we're going to seize a resource. In other words, in order to get to this next stage of being treated, we need to have someone who comes and is reserved for us. So we're going to reserve a healthcare worker, reserve in the sense that we're now associated with them. We're logically associated with them. We're going to be using their time. They'll be allocated to us. So allocate a healthcare worker was perhaps another way to put it. Okay, now ladies and gentlemen, you'll notice the C's needs to know what are you seizing, what resource? And ladies and gentlemen, let us add now a resource pool. Okay? Okay? It's not a loop, it's a pool. Okay? And we're going to add that resource pool, and we're going to call it healthcare workers. Healthcare workers. Now, if you want to call it nurses, you could do so. You want to call it clinicians, you could do so. If you want to call it nurses' aides, that would also be an option. I'm just going to keep it fairly generic, healthcare workers. Okay? Healthcare workers. And right now we're going to make its capacity 1. It's going to be a single healthcare worker. Okay? And we're going to go up to this reserve healthcare worker, and we're going to add in that resource set, healthcare workers. Okay? So in other words, we went up to C's now, and we said, we want to seize one of these healthcare workers. So a person's going to come in, and the first thing they're going to do is to try to be associated with a healthcare worker. And if there's none available, guess what they're going to do, folks? Suppose that the nurse, the doctor you're going to be seeing is currently busy. What do? You wait. You wait. Now, as we'll see, you may not wait arbitrarily long. You may choose to vote with your feet, but at least you'll start to wait, okay? And that's what typically happens. When a resource is not available in these sort of models, there's a queue that forms. Okay, Okay, ladies and gentlemen, how did I get the healthcare workers? I dragged up a resource pool, which is just a couple, it's just immediately above C.
I meant in the reserve, on the resource tab.
Oh, I did this plus sign, little plus. Did you see that?
Okay, right underneath.
Little plus, and it says, add in a healthcare worker, okay? Okay. I'm sorry?
On the set, it says each full set is one per unit, one by one.
Okay, it's a good point. Suppose you reserved simultaneously a healthcare worker, a bed, in a treatment room or something like that. Would it do them one by one, or would it do them all at a block, either all or nothing? That's important because you can get in deadlock situations where you reserve one and someone else reserves a different one, and each is waiting for the one of the other, and then you're in a pickle. Yeah. And you need some way of breaking the deadlock. If you reserve all at once or nothing at all, you can avoid deadlock. Also, incidentally, if you always reserve them in the same order, you can avoid deadlock. Yeah. Okay. In any case. Okay. So at this point, we're going to wait until we have a healthcare worker. Once we have a healthcare worker, that healthcare worker is going to administer us some care. So there's going to be represented by a delay. Now, this delay is going to be called treat. It's a point of significance when it comes to health. Okay? So I just dragged in this delay, which is located about, it's on the order of 10 or so above, about 8 or 9 above the last ones we've been looking at, the resource pool. So I add in, it's above, it's just above that delay here. Yeah. Do you see that? Do people see that? Delay. So this is going to actually represent a treatment process. So once you've got the healthcare worker, once you've waited for that, they come and they've taken you and they're going to go. Then they've got to do something with you. So if it's a vaccination clinic, they've got to get the needle ready and talk with you and jab it and take it out and talk to you a little bit more and let you go. Or if this is someone who's examining, an injury, they've got to do a workup and assess it and so on. So there's going to be typically some variability. Okay. Now, for treat, we have to specify a delay time here. Okay, a delay time. So we're going to specify a delay time here of associated with this for treat of a minimum of 30 minutes. This is going to be called a triangular distribution. It extends from 30 minutes. Its most common value is 45 minutes, and its largest possible value is 90 minutes. Okay? Okay. Yes?
Given the model's running in years, how does it know it's minutes?
This is what I'm about to do.
Okay.
Times minute.
Right, okay. Yeah.
Remember that?
Yeah.
Yeah.
So what's the 30 again? That's
30, the minimum is 30 minutes. The maximum is 90. The most common one is 45. This is called triangular distribution because it looks like a triangle. Not necessarily symmetric, although it is here. So it extends here from 30 minutes to 90 minutes, and it's most common here. I'm sorry, it's not symmetric here. It's more like this. And it's most common is 45 minutes. Okay? So this is kind of a distribution. It's used quite a lot in operations research type work. Merlin, you heard about the network, apparent network dysfunction. That's great. Much appreciated. Right. Okay. Thanks very much. Yeah. Okay. So here we have a delay time associated with this, folks. A time associated with treatment that's given by this. Let me ask this. Okay, we specified a time associated with treatment. Why haven't we specified a time associated with seizing a healthcare worker? Yeah, because that's an emergent property, and it depends on the availability of resources. If all the resources are taken, you may wait, a day. If there's very few other people, or if you're the only one, you may get it immediately. That's an emergent property, how long reserve healthcare worker takes. Okay? Okay. Next, we're going to now go back and we're going to implement something that's going to determine were we in fact successful in the delivery of care. And based on that, it's going to either cure the person or it won't. So you use this select output block, okay, and this is going to be associated with determine outcome. Okay. Okay, so it's going to determine the treatment outcome. And ladies and gentlemen, we'll say with 95% probability, the outcome is favorable. In other words, the outcome is true. Otherwise, it's false. So 95% of the time we'll be successful in conferring care, meaning that the underlying condition will be cured. The underlying condition will be cured. Now, ladies and gentlemen, here starts to be where the solitudes break down. We've been describing this process, and so far there's been no inkling yet that we have some sort of hybrid model, anything about the entities coming through. The entities, ladies and gentlemen, are none other than the agents. The entities are the members of the population who will be presenting for care. And ladies and gentlemen, if we have one of those agents that we've been creating, that we worked on this morning, and we want that agent to be cured, what do we need to do to that agent? What did we do when we cured them in the existing state chart? We sent them a message saying, cured. So we need to send them a message saying that they're cured. If the care was successful, with 95% probability it will be true, in which case we'll be exiting via the true mechanism, and we'll say, excuse me, so I have to be careful here. I'm going to send here, I'm going to send a message to a particular agent. What message will I send? It'll be the cured message. To which agent will I send it, ladies and gentlemen? How do I name the agent? You see it says there's an agent called entity. Entity. So I'm going to send it to the entity. I'm going to send a message to this person that was under treatment saying, you are cured. So when that person gets here, when an entity gets here, we're going to send them a message. If the treatment was successful, we're going to send them a message that says cured. If the treatment was unsuccessful, what do? Nothing. We don't send them a message right here. They remain in an ill state. Ladies and gentlemen, we're most of the way done with this process, but are there any questions on these components I've been putting up there? Yeah, Alan. Entity. So, again, this sort of modeling deals with a process-centric view of, in this case, a care delivery process. So we have a set of processes defined here, and these processes operate upon the set of typically passive actors called entities. Now, the entities here are none other than patients that are flowing through this system.
So that's just the terminology.
Correct. An entity is DAS terminology. In this case, the entities are agents. They are, in fact, the members of the population, and therefore we can send the messages and treat them in every way as a full-bodied agent. We can inquire as to their history and shape our care processes accordingly. We can change their features. We can send the messages, alter their beliefs, their knowledge, their attitude, their habits and behaviors, and through that shape their trajectories going forward. All that can be done within the context of this care delivery. We can further ask those agents about their characteristics, such as what age are they, and have our care processes adapt accordingly. So the agents are the entities here, and we're here, when we're reached this point with a certain entity, we're going to send that entity a message. Does that make sense? Okay, who else has questions on it? It's a different sort of thinking about the system. Each of these blocks is kind of dealing, you describe it, and it's as if it's dealing with an entity. It's going to deal with lots of entities over time, but you think of it as you're describing how does it deal with a certain entity. In this case, it's called entity. Here, how do we deal with this entity? Well, we reserve a healthcare worker for them, and they wait if it's not available. Does that make sense? Yes. Yeah, the entity is... That's right. Yeah, it's like that. These blocks are kind of defined to operate upon, and you specify them in terms of how they operate upon a particular entity. And and you assume kind of the entity is known. You could have specified what the rules are. If you have an entity, what do you do with it? In some cases, you reserve a healthcare worker for it. Sometimes you send that entity to a physical location. You'll make them move in the facility to a location. Other times, you will associate them with some fixed resource, like a room in which they be examined. You know, say a procedure room or an examination room. You associate them with that resource. And other times you may have another resource, like a doctor, accompany them through the facility. But these are agents flowing through it. Okay? Does that make sense? Okay. So we're sending them a message saying that they're cured if the treatment was successful with 95% probability. Otherwise, with 5% probability, it's unfavorable outcome, and they just continue on. Okay, ladies and gentlemen, we're most of the way done. The next thing we're going to do is we're just going to clean up. We're going to release the resources that we previously had reserved. And I'm going to drag this out here, and I'm going to call it release healthcare worker. And I dragged out the release here, just under C's, down in the palette. Does that make sense? And I'm going to double click on this output and click on this input here, because this is going to proceed on to release. This is going to proceed on here to release. Double click here, and then I just click over here. Yeah?
That here is a port.
Yeah. These things are called ports. These things you connect up in this sort of way. You wire them together. So we're going to release the healthcare worker. And finally, ladies and gentlemen, no, because it automatically releases all seized resources. You could tell it, I only want to release certain pools and so on. But in this case, they only have one type, and we'll just release it from all. That's the default. Okay? Okay? And now, ladies and gentlemen, we're going to put in place an exit. And this will be associated with, we'll call it departure. Okay? And now, ladies and gentlemen, we're going to we're going to connect up release healthcare worker for departure. Okay? And at departure, we're going to do one more thing. We're going to send the agent a different message. Okay? We're going to send the agent a message that says, this dot send, a message that says departed healthcare facility. Okay? And we're going to send it to whom? To whom do we send it? The entity. The current person is flowing through here. That's the point of our focus. Okay, ladies and gentlemen, we're just about done here. So I spelled it out, departed healthcare facility. Now this is hazardous business, spelling these things out in strings. There's a much better way to do it with option lists. But I'm trying to keep down the amount of mechanisms here. Maybe we'll see that later. But I'm trying to do it in ways that won't require you to do a lot of extra steps. But you got to be very careful to the spelling. Note how you spell it, and be very careful you spell it again the same way when we handle it. Okay, ladies and gentlemen, there's just one more piece I want to add into this. Just one more piece, okay? I want to make it so that people can bulk, meaning if they spend too much time waiting, they can leave on their own. They'll walk out. And they'll walk out with their health condition still impaired. So we're going to connect up a port here called timeout with this same departure. So if they're not assigned a healthcare worker early, and I'm going to click here, I'm going to click over here, and I'm going to click down like this. Boom. And this connector is bulking, and we're going to set under what conditions they bulk. Okay? So let's go over. So I just added a bulk. Notice here, folks, maybe this would help. Would that help if I zoom in? Okay, I'm going to double click on this, and then we'll have a little bit more screen real estate. And here we go. So we're going to have this, it comes from this T thing, which means timeout, and it comes up here and it goes down to depart. Okay? Just about done with this hybrid model. Just about done with it. I'm sorry? Have to connect to the same one. This is an entry point here. Yeah, it's an entry point. So you have to connect to the same one. It's called bulking. I call this bulking. And I can make its name visible probably. Say that again?
Then everything works left to right.
Yeah.
The entries are on the left. The on the right.
Okay, here's bulking. And I'll put it up there. Bulking. They bulk. They leave.
So we couldn't do all of it. We had to just choose one. I just had to choose the
Okay, that's so wraps it is. Yes.
what's the export on the
Determine outcome.
yeah, whatever the reserve H.
This thing here.
No, the reserve H healthcare worker.
It's actually a P.
Yeah.
It's a P, and I think it's associated with preemption. You can have. I think the idea is you can have entities come in a higher priority than other entities. So you can have people coming in that are maybe especially ill or that are there's sort of a triage. They can preempt other entities. I think that's the idea behind it. I actually haven't thoroughly used it, so I'm not going to be able to speak with authority. But yes.
I'll make a point about any of these particular things. It's really easy to forget that the any logic help exists in the top bars. So these little guys with the 5, white squares sitting on them, it doesn't always make a lot of sense what they are when you're looking straight at it. But if you go to the top bar, you click on help, any logic help, and you search for what that's called. For instance, C, there's a very large page about how it works, what the different ports are called, why you would connect them, the parameters that exist, what all fields are. It's very, very, very helpful. So when in doubt, check the help menu.
Yeah, that's good. So this is bulking, and we're going to put in the conditions for bulking here. So if you go on the left-hand side, we're going to go down. We're selecting the C's, and we'll go down. And what we can find here is that there's going to be a box that says Enable Exit on Timeout. And we're going to click that, and it lets us say what this timeout is, this point where people are going to walk. And we're going to set it to be a triangular distribution. Between, make it 60 minutes, 90 minutes, and 120 minutes times minute here, okay? So in other words, it'll be 60 minutes minimum, 90 minutes most common value, and 120 minutes maximum. People are willing to wait, okay? So they'll balk otherwise. They'll go up and up above there, okay? They'll balk and leave otherwise if they're not served in that time. Triangular? Yep, triangular. I'll go put it up on the big screen here. There we are. Oh, sorry. This should be. I don't know why that. There's a bunch of cruft at the end. There we go. Okay. Yes, question? No, sorry. Stretching. Okay. Other questions?
Well, what about the 5% of work cured?
So they're going back home without their state resolved.
Yeah.
You might think of them as kind of hopeful, but they don't really know, and they're going to represent.
Okay.
They're going to represent for care because they're still ill. They're going to say, oh man, I'm still not feeling good. They thought they fixed it, but they must not have. I'm going to go back for care. Does that make sense? They're going to leave the care. They'd be told, okay, we think we got it, but they're going to discover later they're still feeling lousy. They'll represent. Okay, ladies and gentlemen, do people want me to spend more time looking at this? Do you want to look at anything in particular here?
Can you explain it? If you run this now, just like the old model, in terms of what's happening on the screen?
Yeah, that's because the key link has not yet been made, and we're going to do that right now. Okay? Okay, so ladies and gentlemen, what remains is to put people in here. Yeah, question. Yeah. So no, this is I'm almost certain that what this relates to is if there's certain resource units that were sought for a given agent. Let's suppose this agent needs a bed, and they need a doctor, and they need a examination room to be allocated for them to be examined. Okay, for an HPD or something like that. So you have this. You have maybe the bed at hand that's brought there, but the doctor is not yet available and the room isn't available. And then let's suppose they balk because the doctor is still not available after 60 minutes and they walk out. They walk out of the facility. The question is, what do you do with the bed then? Do you keep it in that area where the patient was, or do you return it to its home location, or do you go through some sort of wrap-up procedure, which is a procedure to sort of release that resource? So that relates to the sort of resources that are allocated, and I think it's particularly when there's multiple types of resources, and one is still not available when the others are, and they balk because of that. They're awaiting. One's been reserved for them, and the other's still not available. They leave. What do you do with that? You bring it all the way back to where it came from, or you keep it here hoping that the bed will be needed soon. Does that make sense? And one thing we're not examining with this model, but is richly supported, but it would take too long to add to do from the ground up, is actual physical representation of people's movements through the facility. Actually moving around, getting beds, bringing the beds there, allocating a doctor, bringing the person with the doctor to an examination room. So you actually have movement. And the point is that because you have movement simulated in a facility, the amount of time it takes for a certain task is emergent. In other words, it depends on how long it takes for the doctor to come from that particular room they were in for care. And so now a lot of things that you would have just programmed in as assumptions about how long it takes, they actually emerge from the facility layout and the vagaries of where the patients are being seen, just like it does in the real world. How long it takes for a doctor to get to the next patient depends if they're 3 floors up in RUH or something like that. So here, we can in general represent physical movement, and you'll find many example models in AnyLogic which do that. And it's not that hard to do. It just would require more time. Okay? Yeah.
Under the reserve it says queue capacity.
Yeah.
That's not referring to the queue weight. That's referring to if there were a number of units drawing from that sort of resolution.
No, it's how big a number of people can be waiting there.
No, it says 100.
Yeah, it says 100 right now. Now, you could set it to be a maximum, in which case, essentially, it's infinite. But think about a room of limited capacity.
Yeah, well, what happens if people keep coming in, like, say there's a major infectious disease outbreak of some kind,
right.
and you exceed 100?
Okay. So, in this case, if we kept this at 100 and it exceeded that, it would throw a message saying queue capacity has been exceeded. So, what that's kind of telling us, and we might keep that because realistically there's no way they're going to fit in there. And so that's telling us, okay, our simulation is kind of violating our assumptions about what's plausible. Now, we might put in regulatory rules where more people balk if there's lots of people waiting. If they come in and they see, everyone from their street already there, they may say, well, I'm not going to stay here. Yeah, exactly. If there's more than 50 people, they're likely to just walk out immediately. And we might then put that rule in there. So this allows us the flexibility of having some upper limit of capacity specified. But, I mean, if we want it to be treated as essentially unlimited, you can say maximum queue capacity, and it'll just grow and grow and grow. You could have tens of thousands awaiting treatment. Okay? Is that helpful? Other questions? Okay, let's put in the key links then, ladies and gentlemen. What's remaining? Right now, this is great. We have this facility. It's in our clinic. Each clinic is going to have this process. It's wonderful. But what's missing? The person has to go to the facility. They have to become part of that process. They're going to the facility physically, but now they actually have to get into that process. Do they not? They do. So, ladies and gentlemen, where would they enter that process? Well, when they arrive at the care, it's at that point, for example, we might arrive. We could alternatively do it in the entry action of this. Why would you do it in an entry action as opposed to a transition in? There's a very material difference between them with respect to pragmatics. Sometimes, ladies and gentlemen, you have many transitions into a given state, and you'd like the same basic thing to happen. No matter how you arrive, you want the same basic thing to happen. Then it makes sense to put it in an entry action of that state. Because no matter how you get in that state, you want it to happen. Similarly, maybe you have a loop which kind of goes out and comes back in, and you want it to happen every time. On the other hand, if you have a very particular transition which is associated with this specific situation, you might want to put it in this transition, like arriving at care. And we could do it in this case either way. There's only one arrow in. Let's put it arriving at care. Okay, now, ladies and gentlemen, you tell me. Okay, they're arriving at their care. How do I refer to the clinic at which they're arriving? Nearest clinic. Okay, excellent. This dot nearest clinic. And then what did we call the place in that clinic process where they first come in? Does anyone remember? Walk-in. So you'd say dot walk-in, and we're going to say take in myself, take me on, take in this agent, take me into your process. That, ladies and gentlemen, is the crux. That's at the heart of the integration between them. That statement turns this agent into an entity that's going to be simultaneously flowing through the process. There's still an agent in the population in every sense of the word. Their agency will outlast their time in that clinic process, but this puts them into that clinic process during which they're going to be processed in that clinic. They're going to go on and be treated, they're going to have successful treatment or not, or they're going to balk. All through that process, they're going to still be in one of these states and everything. It's just saying, also have me go through this process right now. That is the heart of the matter, right there. Are people okay with that? Yes. Robin.
Did you say that you wanted to do it at the state, not the transition? Or did I misunderstand that?
Oh, I said transition. We'll do it at in this case. It's either way. I'm okay with that. Generally, I try to do it in the state, but in this case, it's kind of an arrival transition. It's flagged in that nice kind of arrival way, and I thought, oh, maybe it would be especially transparent if we did it there. Jeff.
Obviously, I added extra transitions later.
Exactly. It'll be more robust. If you were going to add extra transitions later, it'll be more robust to do it in the entry action. That's really the difference. If you have multiple transitions in, then the entry action is your ticket. And that include loop transitions. Okay? Yes, question.
So we're modeling this for patient care. What would be other situations that you might, could you use this for a pathogen entering a host? Or would it be better to use state models?
I think it'd be more natural, I think, with state-related models. We'll see some hybrid models which have pathogen and host dynamics tomorrow, where we actually have dynamic hybrid models for that. But this sort of process, though, it's not strictly a care facility. For example, that guest lecture I gave on Monday related to TB, there the sort of a person's contact with the TB contact tracing process, even if they're not in a facility during most of that time, you could view that as a care process. If they are going through, think about, for those from the states, Veterans Administration processes, where you have to apply for care and you go through a whole series of vetting and sort of allocation to different regimes. You're part of a care process, but you're not necessarily in a facility. So I don't want to give the impression this is related to a facility, but it's related to when there's a defined process with a sort of a known workflow associated with it that you can use, then it can be fruitful. Another example would be, processes associated with testing or screening people or what have you. Is that at all helpful?
Yeah, I see that. But you could think of a pathogen, Well, I guess there'd be replication of a pathogen, but you can
Right.
think of a pathogen response, an inflammatory response,
Right.
immune response, there's
Right.
some delay, and then,
Yep.
you could look at events
Indeed.
in infectious process.
Indeed.
There's maybe better ways of modeling, but I just don't know
Yeah.
other examples of where you would use the screen events.
Yeah. Well, if you were simulating like field operations for your group, there might be, you might have a process associated with trapping animals, right? So you trap them, as I understand from Maria, you put them in a sort of bag, and then you helicopter them over. All those could be represented in one of these processes, right? And you sort of, and depending on the number of people, it might take a longer time to sort of grab them, or a shorter time, and then it would take a certain amount of time to weigh them and extract from their tonsils, et cetera, and then an amount of time to fly them back. And so you could represent one of these processes, and one of the advantages of that would be you could say, well, suppose we had Kurt in addition to your graduate students aboard. How much would he speed up? How many deer you could test in the course of a day? And you see what I mean?
Yeah, so that's more process.
That's more process. I don't know. The idea of doing it for biological processes is, I think, intriguing. I will say that maybe there's some elements of certain molecular species binding that, you need contact with a certain species to proceed to the next stage of some reaction or something. But I think we'll see that stock and flow modeling, system dynamics modeling, combined with agent-based modeling is a much more natural combination to simulate pathogen and host response system. Okay? Yeah.
About output then.
Yeah.
At the moment, this model, if I'm right, I would be able to count any times the prevalence of particular ill for any given year,
Yes.
plus the incidence, how many come in ill in any year.
Yes.
But I can also then count how many people are going to a care facility every hour, every week.
Absolutely.
Wow.
And how many people are successfully treated by that care facility? How many people are walking out of the care facility having not sought care? How would the number of care facilities?
I get output at different timescales.
Absolutely.
So I think the answer is obvious, but I can ask it anyway. So if I've got multiple timescales in a model like we have here,
Yes.
do I set, the timescale we set at the beginning, do I set that at the largest timescale as the basics?
I would use it as most convenient. The point is that you can always specify these other little time units that you require. You can always specify them explicitly. So it's a matter of convenience about what's most common for your stakeholders to think of it. So if they see the time, is it most familiar for them to think of it in terms of years or minutes? If we were dealing with minutes, that would be convenient for describing the details of the care process in the facility. But if we said, that over the course of 3 million minutes, this many people were treated, people's eyes would glaze over.
Which is close down to a time.
Yeah.
I can have a room.
Yeah.
I've got epidemiologists and I've got clinicians.
Yeah.
I can have output that's going to talk at rates per thousand and annual incidence rates.
That's right.
Same meaning, I can actually show numbers walking through a clinic per day.
Yes. Yes.
Wow.
And how the number of healthcare workers, the number of available attendings would affect that, the number of how the availability of an extra triage nurse would affect that, how the number of clinics within this area of town might affect, might be reflected in terms of not just the immediate measures of throughput and so on, but in terms of the number of people still, the prevalence of illness in the population, and in terms of balking rates, et cetera. So there's a whole suite of measures in an integrated system. Yeah. Okay. Now we're just about done, ladies and gentlemen, but I want to fix up one or two things. So thus far, we had this time under care being set to 1 day. How long is the time under care now? It's based on a message. It's an emergent property based on how many people are waiting, what's the demand, what's the supply of healthcare workers. That's something that we turn to ask the discrete event model about, the process model. That's not something we're going to set exogenously. It's something that it's going to be determined endogenously. So based on receipt of a certain message, it's under that condition I'm going to go back my state. Now, what is that message? Does anyone remember? Yeah, let's go make sure we copy it correctly. So it's under departure. It's departed healthcare facility. I'm going to put an exclamation point there because I like to sort of say, hey, this is an action that occurred. Okay, great. Departed healthcare facility. I'm, in fact, going to copy that whole darn thing. This is a horrible way to do it. Horrible. We should define an option list that defines the messages, and then we won't make these mistakes. No spelling mistakes. The bugaboo disappears. Okay? Let's go back to person, and I actually defined this exercise where we'd use those. The message is this. Now, ladies and gentlemen, let me ask. This is the key thing. Let me ask you this. Riddle me this. At the time that they're going to leave, what do we need to do? Do we need to send them a cured message anymore? No, that is sent by where? By the clinic process, if it were successful. So this is vestigial, and can be removed. That's all we need. We just need to move them home. Okay. Great. They're leaving the healthcare facility and they're going home. And that is triggered by a message. How is this working? Well, ladies and gentlemen, they're arriving at care and we're enrolling them, ladies and gentlemen, in the healthcare walk-in process. We're taking them into the healthcare process. At some later point, that process they're going to come down this process. Maybe they're going to be successfully treated and go all the way to the end. Maybe they're going to be unsuccessfully treated. They're going to go down to this F state here, indicate a treatment failure, and they're still going to be released and go to departure. Or maybe they're going to balk. They'll come in, they'll see too many people, they're going to wait a long time, and then they're going to leave. In any case, when they leave, they're going to be sending a message, that this thing will be sending a message to them saying that you're done with your care. And it's at that point that they're going to go back here. And it's at that point that that message is going to be received and they're going to go home. Does that make sense to people? Okay. And it's also at this point, note that they're going to be physically moving and they're going to be transitioning back immediately to this not seeking care state. They're no longer seeking care, right? Now, what is it that's going to dictate whether or not they're still ill? What is it that's going to be dictating whether or not they're still ill? Whether or not they were cured, and that came from where? That came from this little flip of the coin here with 95% probability they're cured. You can imagine changing that. Imagine changes to your protocol which might lead to a higher chance of cure but take longer. You could examine endogenously the impact of that. It's going to be a longer delay, but it will lead to a greater chance of being cured. And what you could ask using this sort of model is, okay, if that can be a gain, because we're going to have more, when people are treated, it's more likely they'll be treated successfully, 98% instead of 95%, or because it takes longer to treat them, are more people going to balk. And therefore, we're going to have less success overall for those who are treated. Sure, we treat them better, but we're going to be losing more people, and therefore it's going to all be a net loss. That is what this sort of model can help you answer. Yes, Chris?
So that whole transition is irrelevant.
The whole?
The transition from health to healthy.
It's
irrelevant. It's waiting for a message that's never going to come. It's not been removed from the active care. And so it doesn't hurt.
No, it's still being sent. It's just being sent from here now.
No, that's the message being sent to the receiving for the cure transition in the person.
Yep, this transition here. Yep, that's going to be the receiving end of this message. So if this is sent, if they come up here with 95% probability they're going to be cured, it's sending them a message, and this is what allows that message to actually have an effect. If they're ill, receipt of that message will lead them to be healthy. Does that make sense? Okay, ladies and gentlemen, should we run this thing? Okay. Okay, here are the people presenting for care. They're coming to the clinic in some numbers. Okay, let's go down to the level at the clinic. Here's a clinic here. This is actually treated. You could see from the numbers here how many people it's treated, how many people are balking. There's actually no one balking yet. This is a very active clinic. You could see some of them gather more numbers than others. This is clinic number 0. Here's clinic number 1. Here's clinic number 2. Right? And we can speed it up. You could see over treating 5,000, 6,000 people, we have yet to have a single balk.
What's the time frame for this? Is it just going through days?
This is actually years. Yeah, and possibly I should have chosen it more artfully, but yeah, we could set it to any number of different time units. Here I chose years, which maybe wasn't the best choice. Okay, so the point is here we have an integrated model that can capture these balking. Ladies and gentlemen, I'd like to suggest, just so that we could see the balking in effect, I'd like to suggest that we have the balking limit be lower. In my notes, I actually suggested to have it lower, but I thought I'd make it a larger unit. Let's now set balking to instead occur after, instead of 60, 90, 120 triangular, let's make it 30, 45, and 60. Okay? 30, 45, and 60 minutes, people will balk. Okay? So I'm setting now balking as determined by the C's block here in the clinic to occur at lower thresholds after 30 minutes, 45, or 60, with 45 being most common. Okay, anyone have questions? Let's run this thing then. 30, 45, 60, it's in the C's block of the clinic. Okay?
What did you just do?
I just went to the C's block of the clinic and I set the timeout to occur from 30 with a triangular distribution from 30, minimum of 30, 45, and then 40, and then 60 is the largest value. Okay? Are people ready?
And that was so you could have more people balking?
Yeah, I wanted to see balking behavior going on because it was not being elicited. So here we're going to be running this thing over time, and I thought that those would yes, here we have some balking going on. There's small numbers of balking. It's not large, but here's clinic number 0, clinic number 1, clinic number 2. The different clinics have certain amounts of balking. It's still very low in numbers. I should have really used smaller time units, but.
Where are you seeing the balking? Is that the departure?
Oh, I'm sorry. It's associated with the T transition. I should have emphasized that. So here we go. So I'm looking here and I'm zeroing in, Robin, on this number here associated with T. So folks, sorry, I should have emphasized before, here in these readouts, it's indicating the number of people that have crossed certain thresholds, the number of entities. And so you'll notice, for example, there have been here 45,000 people that have gone through successfully out of this seizing, and there's been about 30 that have now balked.
How do you zoom into it like this?
I do control mouse roll, thing. Now, 4,800 from this particular clinic have had unsuccessful treatments. Clinic number 1 is less busy, and it's at different numbers. Clinic number 0 is also somewhat less busy. This clinic number 2 is really one that's very, very busy, and they're having a fair number of balks. So this is, I think, clinic number 2. So it's drawing people from a more centralized group. So, of course, we could slow this down, and we would find people coming in from their homes and going out cured. Yes? Sorry? It's a good question. There's a couple different ways. One way would be I could click on it and have it print out what number it is. In fact, hey, why don't we do that? That's a great practical question. How do I know which clinic is clinic number 2 here? Should we do it? And then we'll go for a break, and we'll go into project mode. Okay, folks, how do we know which is clinic number 2? Let's do it. So, ladies and gentlemen, go open clinic here. Okay. And if you click on clinic and you click on the icon, what we're going to do is we're going to scroll down to the advanced, and there'll be an on click. And this is all you do. It's the essence of simplicity. You'll say trace LN. This is clinic, and I'll print out the name. You don't even need to say clinic. This is such and such. This is what you do. So I went to clinic, I went to this icon, I went down to the advanced area, and I opened it up, and then under on click, I said trace LN, this is plus this. Who was in Java tutorial yesterday can tell me what this means? I don't mean that. I mean, what stands before us mean? What does the plus mean? Concatenate. It puts the strings together. So it's going to put this is and then the name of the current clinic. So ladies and what's that?
Eureka!
Okay. So shall we run it? Shall we run it? Okay. So again, that's this on click here. Shall we run it? Okay. Here we go. Run. Okay. And you want to see which is, let's get these clinics going. Okay. And let's go see their statistics. And here's clinic 0. Here's clinic 1. And here's clinic 2. Clinic 2 has a greater, clinic 2 and clinic 3, or 1 and 2 are both pretty high. Clinic 1 is higher. Okay, let's go see which is clinic 1. Okay, go up, and then let's click on a given clinic. And I'm going to drag this over so you can see what happens as a result. I'm going to click on this clinic. Look at that. This is clinic 1. See that?
Can you show it on the graph itself instead of console?
Yes, you could. Yeah. Yeah, you could have a little pop-up that would say, this is clinic 1, this is clinic 2, this is clinic 3.
Where's the console? How did you do that?
So I clicked here, and it's in this console area. If you don't have a console, you can do View Console. But I thought it would normally be configured to pop up, but I could be wrong. Okay.
Here.
So you do View menu, and you do Console. Select Console. Yeah. Okay. Yeah. So now if you run it and you click on a clinic, yeah, there you go. Okay. Okay. So that's clinic number 1. The others are different clinics. They'll be self-labeling.
And when you're seeing
Yeah.
simulation?
Yeah.
Is that all the clinics, or is that a clinic?
This is clinic number 0 here, and then clinic number 1 is here, and clinic number 2, and the statistics are specific to that clinic. And we can ask, for example, although I'm not looking at it here, you can see, if you click here, you can see what's the utilization here. What's the frequency with time with which things are idle or in use. So to what degree are resources in use, et cetera. Okay?
The next level down is a whole lot of stuff.
Next, you mean down here?
No, where you look clinics to the next level down the hierarchy.
Oh, yeah.
You can show us how to read that at least?
Well, these are these different components of it. So those are the different blocks, which are, so that's the departure block here. And then there's, for example, a treat block here. A treat block is this one here, no? And these are some various properties of it. That's right, and this is sort of the numbers that it's treated, et cetera. And yeah, there's a variety of sub-pieces too. But, yeah. Okay. So, folks, I think we'll break now, and we will reconvene here for projects and do some work on projects. So this is our first hybrid model. You've built it from ground up. I'm glad if any of you want to ask questions or want to still get yours working, feel free to ask. Get one of the TAs here. But otherwise, we'll continue with more hybrid models tomorrow. We'll be going with hybrid models with ABM and SD jointly as well. Okay? Oh, yeah. Sure. So I put in this, and I went down here to advanced, trace cell in, and this is in clinic. Yep. Yep.